Okay, so again, for if anyone here is new and hasn't been part of these classes this week so far, my name is Dustin, and I am a software developer, software engineer, and a teacher. And I have participated, or I learned how to program in a boot camp similar to Lambda School, and loved every second of it. It was a lot of hard work, a lot of hours, but it was really, really good experience. Since then, I've been in development full time and been teaching for probably a little bit more than 2 years or so of that time. So a little bit about Lambda School, if you don't know already. We teach development, web development, and computer science in the course here. We have other areas of discipline, iOS, machine learning, and a few more beyond that. So it's an opportunity to learn a lot of different things, which is really cool. If you are signed up for this class, you're probably interested in the web development 6-month course through Lambda School. And how that breaks down is we teach 3 months of web development, so you get the practical experience and knowledge that you need to be a web developer. And then the next 3 months, we teach computer science, the more academic side of programming, a lot of algorithms, a lot of object-oriented programming, and you learn some Python in there, data manipulation, all those good things. So it's a really, really great program, one of the best I've seen, because it combines both the practical experience and knowledge you need to be a web developer, but also gives you the more academic knowledge and experience through the computer science program that you would get in a more traditional program like a college degree. So by the end of 6 months, in that short period of time, and at a fraction of the cost, you get the same knowledge and quite a bit more than you would just getting a developing CS degree through a university, which is really cool. We've been around for a year, a little bit more than a year, and our first set of graduates have just started their career searching, and there's already really fantastic numbers for who is getting hired out of Lambda School. And I think it's because of the way the class and curriculum is structured. So being a boot camp grad myself and in the industry for a few years, highly recommend Lambda School and the program that we're teaching here. Cool. So let's get started with our class. Let me share my screen here. This will be the last class for this week, and then next week we're going to have a little bit different schedule because of 4th of July. So we've got 4th of July coming up next week, so we'll have class on Monday and Tuesday, and then no class on Wednesday, and we'll do the last 2 days on Thursday and Friday next week. So just a heads up for that. The normal schedule is just Monday through Thursday, 2 weeks in a row. We're changing that next week for the holiday. Cool. So where are we at today? Today we're learning control flow in JavaScript. And we'll talk about what that is, and we'll learn a few things today that help us to control the flow of our code as your browser or the computer is executing your JavaScript. So in order to understand that, it's important for us to understand a few of these first questions that I've got up here. We have to know how JavaScript is actually executed when a computer runs your code. We want to know why this idea of the flow of JavaScript is important, and we need to know what an expression is to kind of help us start to build our code in such a way that it makes the flow of the execution work for what we want it to do. So how is JavaScript executed? For the most part, JavaScript is executed on your file from top to bottom, left to right. So just like reading, if we have a variable declared here, and we give it a value, we'll just make it a string. And then later on, we want to access that variable and recall that variable from the computer memory. We can do that. So you see here, we're accessing that variable, and Replit is outputting it here in this console. This, if we move this above, this works because got caps on. This works because JavaScript is executing from the top down. Now this example doesn't work. So we've got new variable up here that we're trying to recall or access from the computer's memory, but above it, we haven't set a variable called new variable yet. We haven't declared this variable and given it a value. And so let's just make sure that I am speaking the truth here. Okay, good. So we're trying to log this variable to the console, and it's not working. It's coming through as undefined because it hasn't been declared yet. It gets declared 2 lines later, right here on line 13. So let's comment this out, and we'll say returns undefined, or output. We'll say outputs. Because it's not yet declared. So now if we do the same thing here, and actually let's keep this uncommented. This is now going to output hello, because above it we have now declared this variable. So top to bottom there, when you get into JavaScript a little bit more, there's some exceptions that you run into that could be some gotchas with JavaScript, but that's far down the line when we're doing a lot more complicated things with JavaScript, so they're not important cases right now for you to learn. So for right now, we just want to know that JavaScript is executed top to bottom, 1 line at a time. So why is flow important? The control flow in JavaScript, with certain, like we learned about if statements yesterday, with things like if statements, we can kind of control which lines get executed and when they get executed. So if we're thinking about top-down execution in our JavaScript file, there's sometimes that we don't want a line of code to be executed until certain conditions are true. And so we can use things like if statements to basically block a line of code from being run until it meets certain conditions. And so JavaScript, the JavaScript engine will start at the top. It will be executing line by line down the file. It'll get to your if statement. And let's say you don't want that piece of code to run yet because the condition hasn't been met. So it would skip everything that's inside that if statement, and it would get to the bottom of that if statement, and it would continue executing down the file. And then we can do things like call functions to get the JavaScript engine to rerun pieces of code and get the engine back to that part that was skipped previously. And now the conditions have been met, and now we want that code executed. So that's kind of the idea of control flow, is we want to be able to, we want to tell the computer when to execute certain lines of code and when not to. And so it's important for us to kind of have that idea of JavaScript flow, so that we can make sure that we're executing the things that we need to at the right time. So that helps us understand why flow is important. So as part of this, we need to understand what an expression is in JavaScript. We're going to be using this word a lot today through the rest of the lesson and through the rest of, probably through the rest of the JavaScript section. I've provided a definition right here. An expression is a set of JavaScript code that evaluates to a single value. So it's going to, well, we'll keep reading. An expression either assigns a value to a variable, or it simply is a value. So right here, line 13, this is an expression. This is the type of expression that is assigning a value. So this line of code evaluates down to a single value and assigns that value to this variable. So if we were to just write a string right here, this is an expression, a JavaScript expression. It's not assigning a value like this line up here is. It just simply is a JavaScript value. If we move this down actually below here, let's do this. Let's put this up here under this question, because that's what we were talking about for that stuff. And now we're talking about expressions. So down here, let's set a new variable, const x equals 10. So this is an expression that's assigning a value. And let's say we just do the number 10 right here on its own line. This is also an expression. It's just a set of code that is evaluating to a single value. If we run that, then we see that on line 20, it indeed is a value. If we say 20, so we don't get it confused with line 18, we're getting this output here just because it's the last line in our replit file. And so the replit file on this green line is always going to just in the console give the value of the expression that's on the last line of the file. So there's nothing else down here. These are all commented out. So this is the last thing it sees, and it's going to output that here right here. So these are both expressions in JavaScript. These are very simple expressions. We can get into a lot more complicated expressions. For example, all of the operators that we talked about yesterday, and even the new ones that we're going to learn today, are simply JavaScript expressions. This part right here in our definition, let's do this. JS code means or can be literals, can be types, can be expressions themselves. So there's a lot of things that kind of make up what this is. So it's a set of any of these things that will evaluate down to a single value. Hopefully that's not confusing. If that just got confusing, just ignore that line right there. Okay, so let's look at some expressions using operators. We've got the 4 math operators we learned yesterday. So we'll skip those because those are that's basically what we learned in high school math. Let's talk about these 2 new ones. In fact, let's drop them down to their own line here. So what is the plus plus and the minus minus? These are operators. The first one is the increment operator, and the second one is the decrement. So this basically performs a very simple math function for us, a math operation for us, of adding or subtracting 1 from the value of whatever this is, of the variable that this is tagged onto. So if we set a variable called number, and let's set that to 0, and then we can recall that variable, and we can say plus plus. So we're tagging this operator on the tail end of this variable, and let's see what it outputs. So we have an error, assignment to a constant variable. So right now I'm trying to change the value of num, which we can't do because we declared it as a constant variable. So we're going to use let to let us do that. Then we will console.log, actually we'll just say num right here. There we go. So now we've taken the value of num, which started at 0, and we've incremented it by 1 by 1. So 0 plus 1 is 1. If we do it again, and again, then we should have 3. There we go. So the increment just adds by 1. Decrement is going to do the opposite and subtract by 1. So here, num is 3. Down here, we're going to subtract 1 on line 44, and then again on line 46. So num should be 1. And let's see if that is true. And there we go. So at this point, after running all these expressions, we get down to the point where num is 1. Pretty easy stuff. Basically plus 1, minus 1. So those are our math operators: plus, minus, times, divide, plus 1, minus 1. Let's look at, and each of these lines is an expression. Each of these lines is a piece of code that is going to evaluate down to a single value. So let's look at our comparison operators. We learned about these 4 yesterday. Again, they're the same things that we see in algebra class. Greater than, less than, greater than or equal to, less than or equal to. Now we've got these new ones, the equals equals, the triple equals, and the doesn't equal over here. I want you to think about for a second we're going to write some JavaScript expressions. I want you to think about what these expressions are going to evaluate down to. What is the value of these expressions? So I'm going to write out a couple of them, and I want you to think for a minute what that's going to evaluate to. We've already used X, so let's go ahead and use Y and Z. Okay. These expressions are basically just the value that we're giving it here. So this is evaluating down to 2, this is evaluating down to 5, and while it's evaluating, after it evaluates down to that value, we're setting it in a variable. So I'm going to write another expression, and I want you to think of what the value is after the JavaScript engine evaluates or runs this line of code. So here we have an expression. What does this evaluate to? What value does this evaluate down to? So sometimes it's easier just to read it in kind of human language. Is Y less than Z? Is 2 less than 5? Yes, Y is less than Z. So this is going to evaluate to true. Oh, I do that way too much, even in my daily work. So we expect this expression to evaluate down to a Boolean value of true. And if we run this, there it is. If we were to do the opposite, let's say Z is less than Y, then we expect this to evaluate down to false, of course. And there we go, false. Let's go ahead and comment out these so we don't get that in our input in our console every time. There we go. Okay, so comparison operators are going to evaluate down to Boolean values. It's either going to be true or it's going to be false when we are comparing one thing to another. And that makes sense. That makes sense to our human brains after we've gone through math classes and we've learned that things are different or they're equal, things are less than, or the value is lower than or higher than a different value. It is logical. Programming languages are just logic. So now let's move on to these new operators. The one that we'll use them, or this double equal, we're not really going to use very much, and I'll talk about why in a second. These are the two that we're going to use most often. And basically what this is saying is instead of less than or equal to, this is saying is this equal to this other value. So we can say y is y equal to z. Is 2 equal to 5? If we run that, we expect false because 2 is not equal to 5, right? So that's the triple equals. It's just comparing these two values straight across. The exclamation point equals equals is also comparing these straight across, but it's asking if they are not equal to each other. So this is asking, are these two values equal to each other? They're not, so it outputs false. This is asking if they are not equal to each other, which is true. So we expect this to output true. And boom, right there. Love it when things work correctly. So what about this double equals? This is where it gets a little bit tricky because, well, let's not talk about that quite yet. We'll talk about that right down here in just a second. I want to look at one more thing with our triple equals. So let's do const name equals, let's go with Spider-Man. And actually, let's do like this: name Tony const superhero name Iron Man. So we've got two variables, which are their values are strings. We wouldn't really use these operators up here to compare the values of name and superhero name because they're not numbers. These are used with numbers. But we can use this idea of the triple equals and the not equal to compare these two straight across. So we can say name is equal to superhero name. And we would, of course, expect this to evaluate down to false. And it does. So let's copy this. And let's say is not equal to, does name not equal superhero name? We expect this to evaluate to true. What if we had const other name equals Tony? Now when we compare these straight across, when we compare name to other name, are they equal? They will be, that will be true. And then conversely, are they not equal? False. They are equal. So this will return false. Sometimes this can catch you off guard a little bit because with the not equal, you have to kind of think in that double negative line of thought, and that can be tough sometimes. So just be careful when you're working on these with these comparison operators that you're thinking in the correct way, because it can get you sometimes. All right, so let's talk about the difference between 1 equal sign, 2 equal sign, and 3 equal sign. It's pretty easy to think, all right, well, I need to see if name is equal to superhero name and do something like that. But this is not correct if we're trying to compare two things. Think for a second about when we've used just a single equal sign and what that single equal sign is doing. So as you see up here on these, on 75, 77, and 79, we're using a single equal sign to declare a variable and to give that variable a value. So that's what the single equal sign is for, is to give something a value in the computer memory. Right now, if I hit run, we're going to get an error out here saying that we're trying to change a constant variable. Because right now we've said that name is a constant of Tony, and we cannot change that because it is a constant variable. Down here on line 92, this expression is not comparing these two variables. It's trying to set a new value to name using a single equal sign. We're trying to say, hey, name should be set to Iron Man. Right? That's what this line is trying to do. But because name is a constant variable, then it gives us the error assignment to constant variable. So it's not even going to let us do that. Now, if we did let, it actually would let us do that. And then we would see that name now equals Iron Man. This is something that is good to learn, that you can set a variable with another variable. It doesn't have to be it doesn't have to be a literal JavaScript thing. Right? It doesn't have to be a literal string. It doesn't have to be a literal number. We can set variables using other variables, and it will take the value of this variable, which is Iron Man, and it will give that value to name, as we see up here. So good thing to learn real quick. But let's change this all back because we want to keep these all working correctly. By the way, when I give you this URL to come back and study with, it would be really annoying to have to go through and comment everything out just so you can see just so you can run it with this being the last line of code, right? So instead of doing that, if you want to look at this expression and make sure it's doing what I commented over here, just do console, just wrap it in a console.log. Just wrap parentheses around this expression. And then, oh, we need to not do this anymore. We'll just comment that out. And then you get the console log of true, and you still get the output of the name down here. But we didn't have to go through and make this line, this one line, be the last line of code. So, cool. So that is our comparisons. Oh, nope, let's talk about the double equals. Almost moved on. So we're going to comment this out and leave a little note here. This is a really, really common mistake that we think this is going to compare these two things side to side. Let's go ahead and erase that one. Okay. So the next one that we want to do is the double equals. So this will work. This is comparing these two variables side to side, and it is going to see that they equal each other, and it will output true. But it comes with a catch when we do the double equals. So here's the catch. And this is a really important catch that, again, at this point in your learning, I would say just completely stay away from the double equals because of this catch until you have the knowledge and experience to do this in the correct way. So let's say we've got const real number equals 1. And we have const string number equals 1 in a string. We talked about yesterday how these are not the same things, right? This is a number, this is a string. The character inside the string is the same character as this number here, but they are different JavaScript types, and they are the same, or they're not the same thing, right? So if we were to ask JavaScript to evaluate and compare with a triple equals these two things, that's going to output false. But if we were to do the same exact thing and use a double equals, we actually get true, even though they're not equal to each other. Why is that? The double equals ignores types. And it just looks at, is this character going to be the same as this character here? And that will cause some real problems, because let's say you're running a function and you're trying to take a variable that you think is a number and add it to another variable, but you don't want to run, and you're trying to run this math operation and say like x plus y, return x plus y, and you're trying to add up these two numbers, and you do a check on your two numbers, on your two variables, on x and y, to see if they are equal. And if they're equal, then you're just going to multiply x by 2 because that gives you the same result. So let's just say if, let's actually write this all out. So let's go const, we've already used x, y, and z, so let's go const first equals 4. This is a little bit contrived. But I think it will illustrate well enough why we don't want to use the double equals. So we're going to use our if statement. We're going to say if first equals second. We're going to run some code if they equal each other. So let's just console.log they are the same. When we run this, we expect to see that console log here, and we're going to also output first plus second. And we get the number 8. So we console log they are the same, and we get the number 8. Well, let's write this again. But instead, we're going to use third here, and we're just going to use our double quote. Look. So using a double quote is going to mess all of this up. They are okay, let's see what happens. Oh, that's okay. We'll leave that console logging for now. So we should not, we're trying to see if first and third are equal. We're comparing them, trying to see if they're equal so that we can run this block of code, these two lines. But they're actually not equal to each other. One is a number and one is a string. So since we're using the double quotes, we find it actually allows, this is going to evaluate to true, just like it did right up here. This evaluates to true, and it will let us enter, it will let the JavaScript engine run these two lines of code. So we use the double quotes, we got this console log, and we're expecting this to output eight, but it outputs a string of 44. So remember when we did this yesterday where we used the math operator, the addition operator, to combine two strings? And instead of doing 4 plus 4 equals 8, it does 4 plus string 4 equals 44. So when we use the double quotes, it's going to mess things up. Unless you do it very, very purposefully, which at this point, you're going to run into enough problems that I just would highly recommend not using double quotes. So that's a long example, a long explanation of the difference between these three comparison operators and why we don't want to use double equals. If you have any questions on that, feel free to reach out to me afterward. But yeah, just stick with, moral of the story is stick with triple equals when we want to compare two values. Okay, so beyond our comparison operators and our math operators, we've got logical operators. And what this does is it allows us to combine more than one equality expressions. So it lets us use more than one of these expressions up here when we're comparing different values. For example, let's say we have 10 is less than 5. So this is the and operator. This is the or operator. And not. I don't know if that's technically what it's called, but that's what we're going to call it for right now. So say we want to check to see if two expressions are true. We simply just put this double ampersand in between. So is 10 greater than 5 and is 5 greater than 1? And that will evaluate down to true. We can go ahead and comment these console logs out here, just so they're not showing up in our console. This is true. What happens if we flip this one This expression, this first expression, this is going to evaluate to false, by the way. This whole line evaluates down to 1. This is an expression made up of 2 expressions. But this full expression here is going to evaluate down to 1 value, which is false. Because it's going to check this expression, say, is 10 greater than 5? Yes, it is. Is 5 less than 1? No, it's not. So it will say that this is false. Okay. When you're using the AND operator, both values need to be true, or all values need to be true in order for it to evaluate down to true. If we've got a string of these in the same expression, something like this, and every single one of them is true except for 1, it will still evaluate down to false. So when we're using the AND, then we're telling the computer that we want to see if every single expression around the AND operator is true, otherwise output false. The OR is a little bit different. It's checking for just a single value around the OR, around the operator, to be true. And if one of the 2 on either side is true, if either of them are true, then it will output true. So let's check this first one. 10 is greater than 5, or is 5 greater than 1? Both of them are true, so it's going to evaluate down to true. This one, only 1 is true. Only 10 is greater than 5. 5 is not less than 1. So this will still output true because we did get one of them in there to be true. So the only way that this would be false is if both of them, if both expressions on either side evaluate to false. So now we've made it evaluate down to false. So those are our logical operators. This one here is kind of interesting. So in order to understand this one, we have to learn something new about JavaScript and expressions. And that is that you can, and a lot of times should, wrap your expressions in parentheses. So let's declare some variables here. Const animal equals bear. Const second animal is also going to equal bear. And we're going to compare these two. And see if they're the same. So right now this is going to evaluate to false. That should, other name. Second animal. That was really confusing. Whew, okay. My faith in myself has been restored. I was going to go crazy for a second. Okay, that evaluates to true. Of course it does, because we see right here that they are the same. And as we compare them, they should be, this should evaluate to true. Now let's take this, let's take this same expression and let's put this operator in front of it, and let's see what it evaluates to. False. So this is a way that we can, this is kind of a double negative here. So we're saying in this, this is kind of the same as doing, without all of this, as doing the does not equal. This also evaluates to false. It's just a different way to write that. This also is useful when you want to, well, I'm not going to get into that right now. More when we get into functions and based on something, flip the Boolean value of something. So this helps us to change the Boolean value of an expression or a variable to the other Boolean value. Yeah, but we will get more into that next week. Okay, so we've got, this is a lot to kind of take in. I think the comparison operators are pretty simple. Does the thing on the left of this operator equal the thing on the right? Does it not equal the thing on the right? This can feel and appear complicated, but you just have to really try and think through the logic of what's happening. And it actually makes it a lot easier to wrap everything inside parentheses like this. So you can say, okay, if we're going to break down this line of code, we see that we have a JavaScript expression here, and we've got an expression here. And those two expressions are part of a larger expression on this whole line. So we've got the AND operator, and we're looking for both. So what is this whole line going to evaluate down to? Well, it's going to evaluate down to true or false. How do we get to that point that it's going to evaluate down to true or false? Well, we first need to look at this. We're using the AND, so we're looking for both sides to be true in order for this to evaluate to be true. In order for the whole expression to evaluate to true. Okay, same thing down here. The OR operator is looking for one of the two expressions to be true in order for the whole expression to evaluate to true. So let's look at this example again. We've got an expression. We're trying to think logically in our minds. What is this line of code going to, what is this expression going to evaluate down to? We're using a logical operator, so it has to evaluate to true or false. So we're using the AND, so both expressions on either side of the AND operator need to be true in order for the whole expression to be true. And so this expression evaluates to true, this expression evaluates to true. Both of them on either side have evaluated to true, so the entire operation is going to evaluate down to true. Conversely, this, even though this expression on the left side on this line evaluates to true, this one does not. This evaluates to false. Since since one of them evaluated to false, we didn't get both of them, then this whole expression is going to evaluate to false. But if this was an or, and we just need one of them to pass the test, this would evaluate to true. But it's not. It's an ampersand, double ampersand, so it's an and operator. So it's going to evaluate down to false. So this stuff can look complicated, but we just have to start thinking about where is there a smaller expression here, and what is that evaluating down to, and what does that mean for the entire line of code. To understand that, it helps to understand the order of evaluation, which is very simple. It's just going to go left to right. And what's cool about this is the JavaScript engine isn't going to run, isn't necessarily going to go through the entire sequence. So in this line of code, the JavaScript engine evaluated just this first expression. Oh, okay. That's not true because I haven't changed this yet. If we do that, then what I'm saying is true. All right. So it's not going to do more work than it needs to. It's not going to, if it sees that we're comparing two JavaScripts and expressions, it's going to look at this first one because it goes left to right. And if this isn't true, it won't even bother to look at this expression because it knows, well, if a single one of these expressions is false, I just output false. So if this expression here is false, there's no reason for it to even look at this expression. And so it will automatically output false without even evaluating this expression, which is good for us because we have so much code that we're trying to have it evaluate and have run inside our browser that we don't want it to do more work than it needs to. We want to keep our code as lean and fast as possible. The more that the JavaScript engine has to do, the slower it starts to become. And we've all been on websites that are very slow and they feel clunky, and we just don't want to be in that website anymore, and we start to lose users because your website's slow. So this is a good thing for us. So just remember that if a single one of these comes back, or if the first one comes back as false, the JavaScript engine isn't even going to bother with this second one. Using parens I kind of covered with this example. I believe that using parentheses will make it so that this actually does get run. So if you use parens, then you're kind of forcing the JavaScript engine to run that. I'm going to make a note right after this class to double check on that, but I believe that using parentheses will actually force the JavaScript engine to run that piece of code. Okay. Logical operators, there's a lot to it, but you just have to really think logically about it and just go one piece at a time. Okay, so now we come to this idea of null and undefined. These are actually a couple of interesting values that can be output by an expression. So if we just say some random variable right here. Has this been assigned a value anywhere? It has not. So what is this going to evaluate down to? This is a JavaScript expression. What is it going to evaluate down to? Oh, it just says it's not defined. So this is undefined. It is undefined is returned if what you're looking for does not exist. If we were to say, if we were to come down here, this is going to throw an error every time. If we're going to come down here and do this, now will that let us run? $188. Nope, it's not going to let us run. That's okay. We'll just comment that out. Doesn't exist. So now let's come down here and let's declare a variable, but let's not give it a value. Let's not say this is equal to anything. Let's just do that. Maybe we can't do that. Interesting. I did not know that that was a problem, that you had to give a const variable a value, but you can give a let variable. Probably because what is the point of writing a const without a value? Because we can't come down here later and say, and give this a value later on, right? So that's probably just this is probably just JavaScript being really smart, saying, okay, let's be honest, if you create this constant variable without a value, you can't change that anywhere, so you're pretty much doing a pointless thing. Okay, so we have to use as let. Now, sometimes as developers, we want to be able to create a variable without a value. And so when that happens, we're just going to set that value to null, because null is set by us when we want to tell other developers that what they're looking for exists but does not have a value. So now, if we recall some random variable, we get the value null. If you see that, then you can know that, all right, someone purposely in this code, someone purposely set the value to null to let us know that, all right, this is a thing, it exists, it has, it is a named variable in our computer, but it doesn't have a value yet. So that's kind of the difference between null and undefined. They're both things that don't have a value. Undefined is returned when it doesn't even exist. Null is returned when we set null so that we can tell other developers that it doesn't have a value, but it does actually exist. Okay, with everything we've learned so far, we can now get to this idea of, in JavaScript, that's called truthiness. In JavaScript, we have truthy values and falsy values. And yes, you heard me correct, truthy and falsy are real things in JavaScript. So let's talk about what they are. A truthy value is a value that is considered true when evaluated in a Boolean context. In a Boolean context. So if we're looking at a value or just a simple expression like a variable, or even this value here, this is an expression that evaluates down to the value 10. When we look at this in a Boolean context, we would say that, all right, is this true? If you look at this line of code, would you say, and you had to choose, you had to give it a Boolean value, would you say it's true or would you say it's false? So we have to think about this as a truthy value, because if we have to choose between calling this true or false, then 10 is a thing, it's something, it's got a value. So yeah, we're going to go ahead and call it true. What about 0? Don't cheat and look down below. Whew. So what about 0? If we had to look at this line of code and say this is either true or this is false, you could probably make a case for it being true. But in JavaScript, kind of have to go with your gut on this one and say that it is false. It's a falsy value. It's not false, the value false, but it is a falsy value. Okay, does that, hopefully that's kind of makes sense looking at these in a Boolean context. Okay, if you take a value and you have to say, if I were to assign this true or false, what would it be? If you would assign it true, it would be a truthy value. It wouldn't be true, the actual value true, it would just be truthy, or it would be falsy. Another way, an easier way to kind of learn this is if a value is not one of the defined falsy values, it is truthy. So what are the defined falsy values? Because everything that is not one of these is always, always, always going to be truthy. Okay, so these are the falsy values. Everything else is truthy. There's only 5 of them. There's false. Actually, there are more. I think there's 7. Let's do a quick look because I'm pretty sure there's 7. Oh man, can't type. I'm trying to finish quickly because we're a little bit past our time. Nan, that's the other one. 1, 2, 3, 4, 5, 6. False, 0. Empty string, null, undefined, nan. False, 0, undefined, null. Oh, so I was incorrect. Okay, there we go. So this is our list of falsy values. False, of course, is falsy. 0, as we learned up here, is falsy. Both undefined and null are falsy values. If you look at either of these values and you say, okay, if I had to assign a true or false value to this, what would I be? False, because null and undefined are both signifying that whatever you're looking for either doesn't exist or doesn't have value to it. An empty string, we know what a string is, right? That is a type in JavaScript. It's some text between quote marks. But an empty string is a falsy value. Keep in mind that an empty or a string, this can kind of get you a string that is just a space character, i.e. string space string, or like that, is truthy. So this one can kind of get you a little bit. There can't be any characters, even the white space blank character there. If there's something inside there, even this white space, it will be truthy. But if it's just an empty string, is considered open close quotation marks without any character inside of it. Okay. Nan stands for not a number, which we saw a little bit yesterday. and can be output by a method or a function that is expecting a number, but it's given like a string, or it's given a Boolean value. If it's given anything but a number, it will output nan, not a number. And that is a falsy value as well. Don't worry about this one so much. We'll get into that a little bit later. Okay, so with all of that we just learned, let's come back to control flow. We've talked about if statements. We use if statements to control the flow of our JavaScript. If 0 is greater than or equal to 12, run this code. It's not, so this code won't be run. So we're always checking for if something is, or we're using if statements to say if these conditions are true, run this set of code. If not, don't run it. So let's say, let's go const, let's do this, fizz equals 3, const buzz equals 5, const fizz buzz equals 15. Okay, then we're going to say if this is not the example I want to use for this. Let's just do this. 3, 5, 15. We'll go over that, I think, on Monday. Okay, if 3 is less than 5, then console log 3 pretty easy to see that. Pretty easy to see that this is going to be console logged, right? 3, yay. So let's come down here. We've learned about if statements. Let's come down here and learn about else if. So let's take this same if statement. And what if we want to run, what if we want to check this value? And then runs and check a second value after we check this value. So let's flip this. Let's say if 3 is greater than 5, console log 3. It's not, we'll go ahead and do that. We get undefined. It's not going to run this console log. But we can now run a second expression to see if another condition is true or not. Else if, so up here we run if 3 is greater than 5, console log 3, else if 3 is less than 5. So we're going to say first block, second block. So of course we're going to skip the first block because this evaluates to false. And we're going to hit the second block because that evaluates to true. What happens if we flip this? So what happens if we have both of them evaluate to true? 3 is greater. If 3 is less than 5, you'll notice that we actually only hit the first block. And that's because we're telling the JavaScript engine that if this is true, run this and then skip to the end and don't run anything else after this block here. So this never even got touched because this evaluated to true. It ran what was inside the curly brackets and then moved on to the end of this code. So keep that in mind. If we want both of them to run, then we simply need to make two different if statements, and then we can have both of them run. But if we're really checking for this if this is true, then run this, or else if this is false, then let's check this one and see if this one's true, but only if this one is false up here. Then we'll run this code. Okay. So now we've got one more to add on to this, and you can do as many else if statements as you want and just keep going with them. And as soon as it hits one that's true, it will break out of this whole block of code. It'll skip everything else that's below it and jump down to the last curly brace and then move on. So keep that in mind that as soon as a true one comes along, it's going to skip all the rest. So now let's look at if, and we'll say Dustin equals Dustin. Or let's see, JavaScript is not case sensitive. JavaScript is case sensitive, so this is not going to work. We'll go ahead and comment out these blocks here, these console logs. So we don't get this to log, right? It's false, it never touched this line of code, it moved on. Now, we could write if Dustin does not equal Dustin, we could use an else if statement here and write a whole new comparison and have that console log, but we don't need to. We just say we want to run this first comparison and say, well, if this is false, if it's true, run this line of code. If it's false, for any other case, we're just going to run this line of code. So if it's false, if it's true, run this, or else run this. So up here, if we're trying to use this kind of in human speak, human language, we could read this kind of as a sentence. If 3 is let's turn this back to greater than. If 3 is greater than 5, run this line of code, or else if 3 is less than 5, run this code. The other check we could do is if 3 is equal to 5. Run this line of code. So we use else if we want to be very specific in our next comparison. If we just want to check if one thing is true, run this. If it's false, run this. Then we just need an if-else statement, not a second comparison operator there. Cool. So we're controlling our flow. We're telling JavaScript exactly which lines to run based on these certain conditions. There's one more way that we can control code, and that is with loops. This will be the last thing that we're going to learn, and so bear with me. We'll be done pretty shortly here. So a for loop is a way that we can evaluate an expression over and over and over again until we want to stop that from happening. It's a 3-step process. This is the syntax for loops is a 3-step process. First, we declare a variable. Then we write a conditional expression, just like we've been doing up here. And after that, we increment the variable. Remember our increment, or we can decrement. And each of these steps is separated by semicolons. So this is, again, just the syntax for loops. Okay, so just like we have our if statements uses the keyword if, we're going to use a keyword for, and then in our parentheses, we're going to do step 1, step 2, then step 3, and then have our curly braces. And inside the braces, we're going to do something with every single iteration. So every time that that we run or evaluate an expression, with our for loop, we're evaluating expressions over and over and over again. And for each time that we do that, it's called an iteration. And we want something to happen with each iteration. So what does that look like in the real world? Usually, we're going to declare a variable with, we always want to do it with let, because we saw earlier that if we increment a const variable, then we're trying to, it'll error out, it'll break, won't let us do that. So we're going to do let, we're going to name our variable I, we're going to say let I equal 0. So that's step 1. Step 2, write a conditional expression. So if I is less than 10, then this is going to happen. Whatever we want to happen with our code will happen. And then increment our variable and do it all over again. So this is, we're starting at 0 and we're waiting until I is no longer less than 10. And when this is no longer true, then we leave the loop and we continue, the JavaScript engine will continue down further in our code. But while I is less than 10, it's going to continue running this over and over and over again, and it won't leave this block of code until this condition is no longer true. So what that looks like is, let's just take this entire thing, and right here, let's declare a variable, const counter equals, let's do equals 0. Actually, let's do equals 100. Okay, and then we're going to do something with this. So we've got our for loop, and inside, let's do 2 console logs. We're going to console log counter, and then we're going to increment counter, and then we're also going to console.log this variable inside here that we declared, because we can still use that variable inside this for loop. Okay, so let's see what happens. First, we're going to do that and do that. Very good. Okay, so we're going to run this. Assignment to constant variables. I'm sorry, let's do let because we're trying to increment that. So, wow, look at that. It console logged a whole bunch of things. The first iteration counter was equal to 100 and I was equal to 0, as we can see in our output. And then during that iteration, after we console logged those two things, we incremented both of them. And then it went through the next loop because I, at this point, was less than 10. So it got ready to do it again. So 0 was less than 10. Second iteration, both variables had been incremented. And you can see it console logged that value incremented. So 101 and 1. So this was our first loop, second loop, third loop, fourth loop, all the way down to our 10th loop right here at 109. I'm going to change this real quick, and I want you to think about what difference changing this from less than is going to make, or changing from less than to less than or equal to is going to make. So think about what difference this is going to make. When is this now going to evaluate as false as opposed to what it was before? So we've actually run our code one extra time. Remember, last time it stopped at 109 and 9. Changing this to less than or equal to 10 allowed us to run it one more time, because as this with less than, when I was 9 right here, it was still true. This still evaluated true. 9 is less than 10, and it let us do one more loop. So it logged out 109 and 9. Then it got incremented to 10, and it said, is 10 less than 10? Nope, that's false. So it didn't do, at that point, it didn't run this with the 10s. Okay, but when we have the equal to, as I gets to 10, is 10 less than or equal to 10? That still evaluates to true, and it'll run this code one extra time. So you got to be careful. A lot of times you don't want this. It can be hard to say, okay, I want this loop to run 10 times, and so I have to make sure that I is equal to 10 so that it runs 10 times. But if you count 1, 2, you'll see that it actually runs 11 times when you set it as equal to. So most of the time we're just going to do less than. There's one more gotcha with for loops, and that is that we can infinitely loop over this set of code. And the way we can do that is if somehow in our comparison, in our condition, we write it in such a way that it will always, always, always be true, and it will never evaluate down to false. And so this just continues to run and run and run. And it's kind of cool to watch. In your settings in Replit, it actually doesn't let an infinite loop happen. It breaks it before it clogs up the JavaScript engine in Chrome. So let's see what happens. Whoa. So this loop right here that we just ran, all we're doing is console logging I. So we're just seeing what is the value of I. It ran literally over 9,000 times, 9,031 times. And it would have continued to run if Replit hadn't stopped it and said, I think you're in an infinite loop here. So you can see all the way from number 0 all the way down, it's logging every single number. So you know that this loop ran 9,032 times. So why did that happen? It's because we wrote a condition that would never, ever, ever be evaluated down to false. I, our variable, will always be greater or equal to 0 because we're just incrementing it higher, right? We're console logging to see what is the value on every single iteration every time that it goes through this loop. And we got all the way up to the 9,000s. So we incremented I over 9,000 times, and it would have continued to do so if Replit hadn't stopped. It said potential infinite loop. You can disable this from settings. So Replit lets you disable infinite loop protection because we call it breaking your browser. You'll break your browser that way. When you've run something so many times, when you go through this infinite loop, that the JavaScript engine gets so bogged down by running this over and over again that it can no longer function. You have broken your browser. A simple refresh fixes that. Actually, sorry, refreshing usually doesn't fix that. You usually have to close down your browser and reopen it. So be careful of those. All right. JavaScript, yay. That was a lot to cover today. With your homework, it's going to be easier to kind of go through these step by step and do it. It really takes, when you're learning these programming languages, it really takes jumping in there and writing code for you to learn what's going on. Since we went so far over time, I'm not going to do questions today, but please feel free. I'll be online for a while. Feel free to Slack me any questions you have. I know we covered a lot and we went really fast. So I just want to make sure that you are learning the material and setting you up for success. So please, please, please reach out to me if you have any questions. Have a good weekend. And we'll be back Monday to learn more. We're going to jump into functions on Monday.